Moving on to our final session before lunch. It focuses on heating and cooling. A distinguished panel will lead the discussion. Our panelists include Mr. Nagahari Krishna L., Director and Head Sales, Industrial Refrigeration and Cold Chain, Danfoss; Mr. Jayanta Chaudhary, Director, Marketing, Alliances and Partnership, Alliance for an Energy Efficient Economy; Dr. Ferno Susay, Managing Partner at Air Design Engineered Solutions; Ms. Harini Santanam, Lead Manager, GIPROC R&D, St. Gobain Research, India. Moderating the session will be Professor Satyanarayanan Sheshadri, Associate Professor, IIT Madras. I invite all the panelists onto the stage. We look forward to a comprehensive exploration of this vital aspect. Welcoming you all.
Good afternoon. Last session before lunch, so we'll make it interesting. I thank all my panelists here today. So the way I would like to do this session, there are going to be no presentations, but there are a few questions. And this session is about heating and cooling, and we have people who are working in all the value streams in the industry. Primary need for cooling or heating in India is mostly cooling is in buildings, commercial buildings. So we have members from the industry who supply the heart or the cooling equipment and the technologies that go into the cooling equipment, and also members from the industry who work on the envelope design of these systems. Also have people from the, I would say, entities that support conscious building and the conscience building on improving the efficiency of these systems. So why is this topic very important? We've been talking about climate change and we've been talking about the impacts of climate change, but the most visible impact is the heat stress in most parts of the cities. And it's very, very well known that as the economy improves and as people become richer, what used to be a luxury starts becoming a necessity, which is cooling, primarily cooling, which is likely to consume more about 50% of the peak energy demand of India in a very, very short amount of time. And that's where we heard the previous speaker talk about the Global Cooling Action Plan led by India. It's primarily with the objective that in another 25 to 30 years, our cooling demand is going to increase by 5 times. And can we manage that kind of cooling demand with the same energy consumption that we do right now? If you are linearly scaling that, then probably we need 5 times the capacity. And our capacity addition targets are not even catching up with the rest of the GDP that is required. And there is already concerns that we do not have enough renewable capacity additions. Our Panchamrit goal said we need to be adding at least 15 gigawatts a year. 15 gigawatts a year right now, going all the way to 50 gigawatts. I don't think we have caught up even with that. So given capacity addition is always going to lag the demand, and our demand is going to only soar, what can we do to that such a way that by way of careful design of systems, by way of careful design of elements that go into the system, that we can address this challenge of demand explosion. So I will request the speakers in order to start with our gentleman from ADES. Now, MEP, they are a consulting company. I like him to give me an introduction, but MEP is one of those crucial elements of large commercial building design. And what have been the advancements and changes in the landscape that you see, which includes design practices, materials and technologies, and how do you look at this as an opportunity for the industry to improve efficiencies by about 2 to 3 times? So while you start, maybe you can introduce yourself. So I will just take about 5 minutes or so to do a quick intro on that. And we'll go through rest of the panelists and then we'll come back to the second round.
Good morning to you all. My name is Ferno. I'm a founder and managing director of Air Design Engineered Solutions. And I am the past president of ISRE. That's all about myself. To answer this question, yes, in MEP, as you all know, the major power energy consumption is into the HVAC system. And the other services like a complete MEP is also plays a major role in energy consumption in any of the buildings. Now, earlier we used to go and take a data manually and arrive certain things. Now it is all changed now. It is now algorithm, AI is involved in here, and it takes algorithms data, it involves and gives a complete real-time data, and it optimizes the capacity of the system, whatever it is, whether it is a HVAC, the total capacity or whatever. And even those days we were just working on the manual heat loads. Now it has become totally, the system runs the whole year program of every hour of 365 days. It gives a optimized, it selects the optimized system and gives us. So likewise, we have a lot of things to, getting into this, this MEP area. And is there any specific question to?
No, the question I want to see is in terms of system design, in terms of architecture of those, what do you see as improvements in the industry that can lead to a 2 to 3 times gain in building energy consumption?
See, now there are data being collected by I just let you know. See, one is the smart building management, the artificial intelligence algorithm to analyze the data from sensors to adjust the HVAC in real time. In real time, this definitely gives, you take, for example, you take a hotel. It completely analyzes the data. What is the kind of a guest? How he is using the air conditioning system, or how is using the other lighting system, and it takes the data. Anytime he enters into the hotel, the total system of the operation is getting into this mode, because it is analyzing the data, gives you optimizing the thing. So likewise, there are all other areas also there where we can really optimize, and even much more than what it consumes.
So
in one of
making, rather than static system, dynamic systems is what you are saying, using a lot of data.
Yes.
Now, we'll come back to that. Now I would like to go to the team from the gentleman from Danfoss to see, while yes, operationally we can improve, collect as much data and make the end use better, but the fundamental architecture, the chilling unit at its heart and the compressor, it has essentially been the same for many decades. The way by which we still cool bulk of the buildings across the world, or even any other cooling system, has been the same. So how does Danfoss as a company see this evolve, and what do you see as the role of the ecosystem? Because Danfoss is a very large international player with various, I would say, activities in this domain. So what do you see as the role of the ecosystem partners, including consultants and architects, academics, and other solution providers play in this? Maybe you introduce yourself.
Hello. Yeah. Good afternoon, everyone. Thank you, Professor, for the question. My name is Krishna. I am representing Danfoss India here. I head the sales for industrial refrigeration and cold chain for Danfoss in India. But prior to this, I have also been working in a lot of policy directives and setting the policies for buildings and air conditionings, and I'm a part of the Bureau of Indian Standards committee. So now coming back to the question that you put, Professor, on compressors being the heart of it, and so you're right that the compressor is the heart of the system, and at least the way we see it is when you say it has stayed the same for many decades, I don't think that is completely true. And the way we do see in terms of future forward is that when you look at the technology for air conditioning or refrigeration per se, the dominant technology that has been there for the past many decades has been the vapor compression technology, where compressors play one of the major role. And when we look at it, even from a future point of view, even when there have been global competitions on looking at alternative solutions, there have been many solutions that have been proposed, including passive cooling, including silica gel as an option. There have been thermal materials that have been used, but all of them have combined some form of vapor compression to achieve what they want to showcase as higher efficiencies. But even those are still not scalable in the manner what we need when we look at the requirements that we look at for cooling, whether it is India or any other part, throughout morning, there have been multiple sessions where people have said that cooling would need so much of energy, and cooling is, when we consider cooling, we all know that the more we cool, the more we heat the planet. And when vapor compression is going, at least at Danfoss and in many other companies, we do see that vapor compression is going to continue to be the dominant technology, at least for the next decade, while there are multiple options and multiple solutions that a lot of companies are working at. So compressor is going to still be the heart of the system, at least for the next decade, where we do see a lot of growth in this sector within the country. And coming to what changes we have seen within compressors in the last many years, if you see 20 years ago, the compressors that were used were largely only reciprocating. But today, if you see, a lot more scroll technology is used. And even within scroll compressors, there are a lot of improvements within scroll compressors that you have seen. There are valves that have been changed to improve the efficiency, and energy efficiency is the first fuel that a lot of us identify, which we do see that there is immense scope to utilize it. Even in the keynote session, in the first session, we saw that in every sector, energy efficiency has the largest gains that we can achieve. And each of these compressors have a lot more to offer. And today, not just compressors, today variable speed compressors have become largely a reality. Today, we need not ask companies or solution providers to look for variable speed as an option. Increasingly, people are looking at variable speed compressors as an option. And over the last 7-8 years, what we have also seen within compressors is that today we have a oil-free magnetic compressor which is available, including from Danfoss, which was the pioneer in it with turbo core compressor. I don't think people thought of having a compressor without oil when we were talking about air conditioning. But compressors have come to that stage where today you have a compressor without oil which can be used. Now, how do you make this more acceptable and people using these kind of options more and more is a question that I guess all of us will have to look at.
Understood.
In terms of future, in terms of what is the compressors, where do we see? We do see that there is a lot of development, and we do see we will be able to quickly come up with compressors which can use more and more natural refrigerants. It could be propane for more and more commercial use. And that's where we believe that the direction of the compressor technology in itself will move. And vapor compression technology will still be the dominant technology, at least for the next decade. And energy efficiency to us is something that we will have to consistently use along with this to up the game.
Sure. Thank you very much. And maybe we'll come to the other part where you see the role of academics and other solution providers play. I'd like to move on to Harini from Saint-Gobain, where while design of MEP and the design of chilling plant is one, the overall building envelope design is something which is often neglected in the overall system design. But it is also a critical element in maintaining comfortable indoor air while minimizing the energy cost. So what are the challenges that you see in utilizing global best practices in a place like India? And what are the some of the attractive emerging solutions that you are now seeing that it's becoming mainstream?
Thank you, Professor. Good morning, everyone. So I'm Harini. I lead the R&D here in Saint Gobain Research India. We are just neighbors from where we are sitting. I lead the R&D for gypsum and related materials. So you probably know Saint Gobain as a glass company, but we do have other materials also, and gypsum is one of them. My background, I am a civil engineer. I have worked in, I'm actually a subject matter expert for concrete, and I used to work in nuclear power plant industry in the US before moving here. So that's me, and an interesting question. So I will try and answer that. I have some pointers. Maybe I'll go through them one by one. Tropical climate, that's what you mentioned. India being hot and humid, the climate across India is not the same. So one thing could work in a particular region may not be suitable or workable in the other area. So that's a difference mainly because of temperature, humidity, rainfall, which may need different materials, different design for the engineer, for the designer to consider. And that's a challenge. And also the high humidity. Many of us talk about temperature, but we ignore the humidity part, but humidity is also quite crucial. And especially in tropical climates where in India especially, we don't use the conventional insulations and ventilation techniques. So that could also lead to issues, and energy efficiency could be a problem. Solar heat gain, right? So there is intense sunlight in many parts of the region, and what happens when we use large glass surfaces? You need to maintain the natural light that comes in. However, you need to maintain the energy efficiency. This is one big challenge in many of the commercial buildings which are, which have a glass envelope. Occupant behavior. So we are all culturally different, and each of us use our household differently. So based on these differences, the amount of humidity one could create within the house is also a challenge which gets ignored most of the times. And these factors must be considered while you design your building, and practicality needs to be considered before you put the building into use. Other thing is, of course, cost implications. Many of these technologies that are available abroad, they are, to implement it here in India, initially it is costlier. So we tend to avoid that, and to get into the adoption and using these technologies is a challenge also. So these are few things that I thought I could share.
Wonderful. Thank you very much, Harini. And an integrative design approach is what we've been looking at. Last year, we had a workshop by Dr. Emery Lovins from the Rocky Mountain Institute, where we did look at many of these options together. I think an isolated approach is probably piecemeal, and it's going to be difficult to scale. But before we go on to that discussion, I would like to request a colleague from AEEE. They have been promoting cooling systems efficiency, and of late, I think I've been hearing a lot about district cooling. In the context of India, given there's huge amount of challenges of doing any centralized activity, what do you see as the role of district cooling emerge and shape up in India? There is a related reason why I'm asking, because I'll come back to that later, but let's hear from him.
Thank you. So yeah, I represent AEEE. Yeah, absolutely. I am not an engineer. I worked in the industry for 2.5 decades, as I said, in the wrong side before jumping into the development sector, trying to make a difference. And I lead the industry relationship for AEEE. And at AEEE, we believe energy efficiency is the first fuel. It's cleanest, cheapest, fastest. And we saw the evidence, I would say, of the importance of energy efficiency in the previous sessions. So talking from there, I think to your question of district energy systems, politically right, not district cooling only. Ashish is smiling there. It is a part of the India Cooling Action Plan that we were we partnered MOEFCC and of course developed the National Cooling Action Plan. So that's something which the world is now recognizing. It's a proven technology, and it's one of the 2-3 things I'd love to talk about from a overall solutions perspective that we believe in. District energy system, especially in India, district cooling can easily provide anywhere between 20 to 50% energy efficiency. It's not a magic bullet. It's not going to be fitting in every situation, but I think there is enough evidence Middle East and Southeast Asia, where the deployments have happened, which can, happen in India. And we're happy to see at least GIFT City is, again, one, we are talking about a 10,000 TR deployment. There is multiple others happening in Telangana and other areas. But I think the scope is huge. I think as part of ICAP, it can probably lead to a 6 or 7 gigawatts of energy, demand offset by 2037 if they are deployed at scale. We released the district cooling guidelines. We worked on that along with BEE and of course GIZ and a consortium, including some of the leading industry partners, including Danfoss, Tabri, and others who are part of it. It's getting there. The policy is there. The adoption and everything is going to be there. So that's going to be one of the things. We did talk about also the RAC and how it's going to go up. So I'll just probably also divert the discussion a little bit from a cooling to more on thermal comfort, if I may. And maybe just 2 more things that we believe for the common man, mass affordable, RAC is not going to be the one. We are talking about maybe a 5-6% penetration today. We are talking about going up to 50% by 2050. And I think at the business and the technology, as usual, is going to be a nightmare. And we discussed that. But what is it for the common mass man? We are betting on 2 major things that AEEE we are working on. One is, super energy efficient fans led by BLDC. We do believe it's like offering 50-60% more efficient solution. There's a 500 million installed base of fans, 50 million probably getting added every year. 10% if we are able to target, we can probably offset 350 megawatts kind of the demand. We are working with energy efficiency, ESL, in a demand aggregation program, trying to create an aggregated demand of about 5 to 10 million BLDC fans over the next few years. Again, as a part of the consortium, we'd love to have all of you join us there. How to really do that can have a huge impact. And that's the solution and bulk procurement, we saw LED, the success story. We believe it can be the next, Ujala in India. And every mass affordable house should have a BLDC fan. Public procurement can bring down the price. We have seen $350 to $50 in case of LED. It can easily be done for BLDC. And the second one I would talk about is evaporative air cooling, especially the indirect direct evaporative air cooling. 1/10 the cost. It could be a fantastic solution. To a point, district cooling is great. Of course, it's going to cater to one particular thing. But from a cooling, mass affordable, these are the other 2 technologies that probably we are betting on, we are working on, we believe in. Thank you.
Thank you. Your name?
I'm Jayant, part of AEEE. I lead the marketing, membership, alliances and partnerships. Thanks.
Thank you, Jayant. Let me start with you with the question. So when you say district cooling is not going to be a silver bullet or a magic bullet, how widespread do you think is it going to be? Is it going to cater to 50% of the needs, 10% of the needs? What do you think is going to happen in the next 15, 20 years?
I think a difficult question. If you see in Dubai and other places, of course, there is a large deployment and we see solution in malls, metros, everywhere. In Singapore again, a lot of these organizations are now coming to India. So question coming over here, large, we spoke about, SEZ data centers, we spoke about, the builders are picking it up. Putting a percentage is going to be difficult. Can we look at a, kind of over the overall solution, we're looking at a 10% or something. Difficult to put in the number, but we do believe large, office complexes, residential complexes, the solution is very practical. IIT, Chennai, this entire complex can probably be, kind of powered by a centralized solution. Moving on to a district energy system, I do believe in North and some of the other places that can also have an impact. But again, I think it's too nascent a stage right now. As I said, the ICAP puts in a number of almost 6 to 7 gigawatts of demand offset by 2037. I think we'd love to see that happen by then. I think scope is huge.
Thank you. IIT Madras, the main campus, by the way, has moved to district cooling. So we do have a campus-wide network of pipelines. The challenge has been, while it addresses the supply side, the building envelope design is not yet. So it just added that much more capacity requirement there. In terms of what we heard right now and the global cooling action plan target of 5x reduction, I do understand BLDC fans and evaporative cooling do contribute, but bulk of the 5x increase was going to be driven by room air conditioners, RACs, and that's still going to happen because of the huge middle class people that's going to come on board. How do we see solutions evolve? Maybe I'll give that to Danfoss to see if 5x need to be achieved, what would Danfoss do?
Well, to me, the consistent questions on cooling go. I mean, I feel like I'm suddenly seeing Game of Thrones and we are awaiting a storm. and obviously here we don't want to build a wall, but all of us want to embrace cooling, you know. And yeah, so be it food, be it comfort, be it vaccines, we all know that cooling is something that all of us need. And the way, at least what we have seen in terms of the cooling demand and the solutions that are available is, while room air conditioners are going to multiply manifold in the next decade, but so is air conditioning that is needed for commercial purposes. So is refrigeration for industrial purposes, so is commercial refrigeration, and so is domestic refrigeration. And when you look at India and the standards that India has built in for, let's say, room air conditioning, it is among the best in the world in terms of the ratings. It's somewhere really on top. And manufacturers are really working towards that, and they are consistently trying to further improve upon that. The way that we look at it is that there is no one size fits all solution. You need to break down the entire cooling demand into multiple facets. And when you look at, let's say, commercial air conditioning, where the commercial buildings, the hospitals, the hotels, all of these play a very large role. Now here you have, even here there are many guidelines, the ECBC is in place, the standards are in place, and the government has done that. But when it comes to implementation, I don't think on ground there is an implementation of any of these standards and guidelines that happens. This is where the stakeholder community comes into play. This is where the policy also comes into play as to how can you mandate these things to happen.
Sure.
That
No,
is
my question was also related to the cooling action plan said the equipment and the hardware efficiencies need to improve by 5 times. So for example, the cooling system, I think one of the target was can the energy demand or energy required per ton of cooling, can it reduce by 5 times?
Yeah, so I'm coming to that.
Yeah.
So while the commercial buildings is one part of it, now one of the things I liked about the topic of today's discussion is, it is cooling and heating, and it is not just cooling. Because invariably we have seen everyone looking at cooling as cooling and heating as heating. And even when there was a global competition, it was more seen from a cooling point of view. Now if you look at it from a cooling and heating point of view, invariably we think that India is a hot country and we don't need heating. So if we have to move towards increasing it for 5x times, I don't think the challenge is with the solutions. The solutions are available. You need to look at integrating them, changing your mindset, and developing the skill sets that are required for the entire community.
Absolutely. So I agree with you completely. So yes, we've been working on heat pumps, more than 400 units deployed in the field, particularly the industrial scale. I think a lot more could be done. Maybe I can ask Harini a question from the material side. Given that we need to improve our efficiency and cut down the demand for cooling, what innovation do you see in materials that can aid this kind of rapid progress that's required?
Sure. I'll touch upon few materials as well as some, systems also. So, I mean, the energy efficiency building, the materials that go into it, it's a field that is evolving, right? It's not there yet. But there are few things that are already existing, especially abroad, and maybe there are those things that can come to India as well. The first one is the BIPV, or the Building Integrated Photovoltaics, which are solar panels which can be directly installed on the envelope of the building, right? It could be on the windows, it could be on the roofs, it could be panels across which can be made use and which can also serve as architectural elements. And then, I don't know how many of you know, but there are dynamic glasses also that are available. So these dynamic glasses, they adjust themselves to the response, they respond to the sunlight, and they tint themselves and allow the energy or the light that is required for the building. And this is one way to control the energy within the building. Then you probably have heard of carbon capture. So there are a lot of technologies that aim to capture the carbon, and then that gets converted into usable products, such as building materials, fuels, and that contributes to the circular carbon economy. There are also these advanced insulation materials. There are nanogels, there are aerogels, nano insulation, and phase change materials which can be also utilized. This can improve the thermal performance and reduce the heat transfer. Other thing, you probably have heard of 3D printing. 3D printing in construction is also catching up. Of course, it is very new in India. And this will allow us to use only the precise material that is required for the building construction. It will reduce the material waste and also make the building more, the design can be made in such a way that you can create an energy efficient building. If you have noticed, the air gap between the walls serves as a insulating material in 3D printed homes. Then there are other things like energy harvesting systems and smart HVAC control, IoT based systems, and other energy storage solutions that they were discussing in the previous sessions also. All that being said, I mean, I was talking about more sophisticated systems, but if you look around, especially in India, all you see is concrete building. We are in a concrete jungle where the heat is just stored there and you end up using air conditioner. We don't accept other kind of materials. There are many more lightweight materials, such as what I was talking earlier, drywall systems and other things, which we don't accept easily because that's in our mindset. We want our home not just for us, we want it for our kids, our grandkids, and so on. So any new technology that comes into, we need to adopt it, accept it, and then move on. So that's a challenge, but let's see how it goes.
I think that's a good cue, going back to you, sir. New technologies, how quick is the end user of the MEP world, and when you say look at consultants and promoting such new, innovations that you want to, how quick is it to adopt? Maybe if you can take 2 minutes, then I will open it up for questions.
Yes, when we work on the materials, building materials, see, we always check with them, select the glass, select the material based on their high efficiency, and also that should allow more light and less heat. So this combinations we normally go with. And not only that, there are so many things that are coming up, like the light, the glass changes according to the orientation. All those things are really helping us to optimize the building load. And not only that, nowadays, all precast buildings, even in this IIT campus, you're constructing a building in 180 days challenge. So the entire auditorium, some auditorium is being constructed here in 180 days with all the system, complete MEP also. So when these are the challenges also involved. So when you talk about the material, it plays a major role. As Cheese was saying, there are so many wonderful materials are available, but we are always stick on to the traditional way of doing the buildings.
That goes back to the customer mindset. Are you able to change the customer mindset based on your interaction and saying that here is an innovative, or the customer always is all that is fine, stick to what is proven?
We always recommend, if you look at buildings in Kerala, see there is a wall construction called rat trap bond, where it creates a cavity and allows a less heat. Even many projects we recommend this. See, one is it gives a thermal conductivity less. The other one is the material consumption also is less, almost 30 to 35%. So we strongly recommend, and sometimes we fight also.
Okay.
But this is a challenge always we will have with the architects.
I think we understand. There's a lot of challenge in trying to introduce. So maybe I'll take a pause here, open it up to the, one.
So to your specific question on RAC that you mentioned, a 5X, so we were part of the Global Cooling Prize, and of course it was won by GREE and Daikin. So the prototypes are getting kind of now developed, but its commercialization is not going to probably happen in the next 8 to 10 years before we actually see that. But I think the best part it is that we have proven that it's possible. The work is happening on the prototyping, and third is there are elements out of it, maybe the dehumidification and the others, which may see a light of day earlier. So, to your specific question, I think that is something that is happening, but that alone is not going to solve the problem. There's a lot of behavioral angle. There is going to be, bundled with DR, distributed energy system. You need to have a combination of it to solve the 5X or the problem that's going to happen in 2050. It's not going to be solved only by technology, not only by RSEs. Yeah.
Wonderful. I think that's a very valid point. We also need to look outside the box, maybe into the seas. Our oceans contain 4-degree water very, very effectively. If district cooling and that can be combined, we can go even beyond 5X, we can go 10X. But nevertheless, we will dream. I'll open the floor up for questions.